Hello, friends. So let's do the deep dive on the convolutional neural network terminologies. So here, the input size of an image determines how much pixels we are having it in the input size, right? The filter that we need to capture the important features, we need to filter the important features of an image and keep it at a one side, and then I'll explain it in a further in a later slides that how to use that, how to capture the important features out of the pixel, right? And this kernel size, how do you define that? What portion of image we need to capture and then extract the important features, so that is a kernel size stride. I'll explain it, stride and padding, I'll explain it when I'll show the further videos, right? So now if you see it over here, this is a kernel size. So if you see here, this is a kernel size we have defined, 3 by 3. So this is an input image, all the black dot is considered as a pixels, right? So we have an 8 into 8 image, uh, mm, 8 into 8 matrix of an input image. And now we need to define the kernel size of the filter. So the kernel size of a filter is 3 by 3. If we'll match with an analogy of a deep neural network, the filter is nothing, is a weight. So this is the input feature and this is the weight which is randomly we need to initialize it, and we need to just define the size of a kernel, of a filter, right? So now what it does it, when this weight would be overlapped with this portion of a input image, it will do the weighted average, do the calculation and extract the important features of this particular image and create a one pixel out of it. So now when you'll execute this into, when you multiply this pixel with this kernel, it will create, extract the important features. Similarly, again it will go from this pixel, it will take this particular pixel and take the important features and extract the important features and create a another pixel. Similarly, it will do it for all the combination of 3 by 3 and create an important feature. This will reduce the size of input image, and then the new image of a pixel would be created which has having a important features of an image. So I'll show it in this particular slide. So if you see, this is an input size and the kernel size we have defined is 3 by 3. The padding, I'll show you what the padding is, and the stride and the dilation. So let's take it simple and then I'll change it this. So this is the input size of a 5 into 5 and we have taken a kernel size of 3 into 3, right? So this is a weight. So over the weight, when this weight, if you'll see, this weight would be overlapping with the input size, it calculates, it does certain calculation and extract the important features and put it into this output. So this 5 into 5 matrix, when it will do the certain calculation and simulation with a weight, it would give an output of a size 2 into 2. So my input image of 5 into 5 would be converted into 2 into 2 image size. This means all the important feature is been captured into 2 into 2 image size, right? So what is padding? So sometimes what has happens over here, that my kernel size, when it does a certain calculation with this particular portion of an image, it doesn't take important features from the edges. So when we'll do the padding, so if I'll do the padding, it's create a padding outside the input size, and this padding is nothing, it's just a zero. With a zero it does the padding, right? So now because of this padding, I can take important features, because my edges is now of an input image is now no more an edges. Now it would be a uh, part of an image which is not considered to be a edge, right? Correct. So that's the reason sometimes we will use the edge, wherein we find that the input features the images would be having a input or important features at the edges also. Correct. And what is a stride? So if I'll take an stride 1, so it goes from here, it takes the important features of 3 by 3 and then it moves here, right? Then it takes an important feature out of this and push the value over here. Then again it shift by one position, but when I'll do the stride 2, it would be shifted by 2. So see, my stride is 2, it has not shift taken it over here, it is shifted by 2 pixels. So now my important my features would be calculated by skipping the 2 pixels. So let's take a look on it. When the stride is 2, so the important features, so it has skip it, it comes first is take the features from this particular portion of the image, and then the second it took from it over here, right? This all are the convolutional visualizer. You can also go and look by uh, this github.io. Okay. And another visualization which is very important, I would like to show it over here. um, can I show it from here? If it, okay, so yes, right. So if you see, this is the input image, this is the input image, and they have already done the padding with 0 values, right? So we have created this image is of 3 channel, red, green and blue. So that's why if you see it over here, we are having a value of red, green and blue. So we are having a 3 channel out of here, and we have defined the filter size of 3 by 3. Since it has a 3 channel, so the filter is also be having a 3 different filters for each filter would denotes with each channel, right? And so this depends how much filter you need to do. Suppose if you are having a 4D image, then the 4 filter would be used at a W0, right? If we are having only black and white image, then only one filter would be required, it is W0. Now, how many times you are initializing a new filter that will create a number of a feature maps? So here we had defined the W0, that is a one filter. By doing a certain calculation with a one filter, it creates a one feature map, it creates a one output. And next time again we will do it for a another filter with a different weights into it, right? And then it would create a new output. So these are the two different feature maps which has been created, and then we'll pass this to input feature map further to do the further calculation. So how the calculation is being done? So this is the first weight, if you see, and these are the 3 channel, red, green and blue. So I'll show it from here. Okay, let's take this pixel. So this pixels would be multiplied by this filter plus, so this is a first input features, this into this, so this is a weighted average, plus this features into this weight, plus this features into this weight, and that creates an output 1, right? So if you see over here, so this features into this plus this feature into this plus this feature into this will give a 1 value. Now once the one filter has been done, another feature map would be created with another filter. First we have created for this filter, and now with this filter. So my 2 feature map would be created. This would be having some important features of an image, and this has captured another important image of the capture, and then later on we'll uh, fetch the important feature from both the filter and try to predict from which category this particular image is of, right? So this is what the convolutional neural network terminology, and this is how the convolutional neural network works. So in further videos I would be explaining it how the calculation done with the filters, and what is the full architecture of a CNN, and how do we execute the CNN architecture end to end. So hope this session would be informative for you all guys. Thank you.